to go over a little bit of lesson 1.3, I'm going to go over the even problems just to hopefully spark some understanding. Keep in mind when we do the first 6 problems that we are operating off of f of n and n. So the input is n. What you get out of it is f of n. For example, in the lesson itself, we were talking about the number of minutes, which would be our n, and our f of n would be the number of dots in each minute. Okay, we called it t and f of t. So for number 2, f of n, we're looking at for when f of n equals 17. For example, there are 17 dots. How many minutes are there when there are 17 dots? Well, we can look here. There are 17 dots, and this tells us there are 6 minutes. So we would write 6. And the value of f of n minus 1. So instead of 6 minutes, we're going to go back 1 minute and see how many dots there are at 5 minutes. Well, in this case, there are 12. That's all we're doing here. Number 4, f of n is 2. So we notice that we have this here. What is the value of n? We look up. Oh, that was when it was 3 minutes. And what is the value of f of n plus 3? Well, n was 2, so 3 more, 1, 2, 3. The value of f of n plus 3 should be 12. For number 6, clean that up. When f of n equals negative 8, again, looking for the f of n value, and sure enough, it is right there. We know that n is 1. What is the value of f of n plus 9? Well, we're going to take this and we're going to jump 9 spaces, or if we just add 1 plus 9, we know that we're looking for the 10th output. Well, the 10th output is right here. It is 37. For the next set of problems, I would typically say not to worry about the easiest. Just find something that is the most effective for you. So maybe you're not going to be thinking about easiest. Maybe you're going to be thinking about most effective. So for number 8, it gives us both equations. It tells us what I need to do. And if I want to find the 50th term, all I know is the first and the second. I've got to find the 50th. So I could take the previous term and add 3 for the 3rd, the 4th, the 5th, the 6th, 7th, 8th, all the way up to the 50th. That sounds like a whole lot of work that I don't want to have to do. Or I can say that I want to find the 50th term and I know that I have a formula that I can plug it into. So y equals 3 times 50 plus 7. 3 times 50 is 150, plus 7 gives me 157. For number 10, same process here. We're trying to think about what is happening. The 8th is 78. The sequence is increasing by 10 at each step. So if I want to find the 9th term, I could plug that number in and subtract. I also know that I can take the previous term and add 10. Since I know the 8th term, and I know that it's increasing by 10 at each step, I know that the 9th term would just have to be the 8th term plus 10. So I could say that 78 plus 10 should give me 88. Now, if you think that the explicit equation is going to be easier for you to use it. Try to think about which one is going to be most effective for you. For number 12, we know our 4th term, it's 80. And we know we're doubling each step. But if I want to find the seventh term, what do I need to do? And this one's a little bit more challenging because for the explicit, that means that I need to take 5 times 2 times 2 times 2 times 2 times 2 times 2 times 2. That's a lot. Or I can take the recursive, which is the previous term times 2. So the fourth is 80. The fifth is 80 times 2, so 160. The sixth is 160 times 2, so 320. And the seventh is the sixth times 2, which is 640. So I think the easiest way to do it is the recursive, because I can pick up where the fourth was, and it's not too far away for me to continue to double. If you wanted to multiply all of those numbers out, 5 times 2 times 2 times 2 times 2 times 2 times 2, awesome. Find the one that's most efficient for you. For the last set, we are looking to evaluate again. So we're looking to solve, and we've done this, and I say again because we've done this in the previous lessons as well. We're plugging in numbers, and we're trying to find answers. So we're trying to break this up, 13, 14, 15, and 16. I'm going to do 14 and 16, and hopefully that helps. I would encourage you to use a calculator, whether it's the Desmos graphing calculator. You can plug these in and you can figure out what the solutions are, or using your own calculator, you can do that as well. So for number 14, we have y equals -3, and then all of that in parentheses to the x power. So we would be looking at -3 to the first power, which is -3. We'd be looking at -2, -3 to the second power, which means -3 times -3 gives me 9. Keep on going, -3 to the third gives me -3 times -3, which is 9, times another -3, which is -27. And if you notice here on the side, we can just start looking at it and multiplying the previous term times -3. So -3 to the fourth equals 81, and -3 to the fifth equals -243. For number 16, same exact process, just a different function that we're using here. We're using y equals 10 to the x power. So we can say that we are going to go 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, and 10 to the fifth power. So we get 10, 100, 1,000. And what you should start seeing here when we're taking 10 to a power of something, there is a relationship between the exponent and how many zeros there are. That's all we're doing here. And then when you're done, you've got that table of values that you can use, and you can start to see that pattern of what is happening here. Am I multiplying? Am I adding? Is there a common ratio? Is there a common difference? Try to start thinking about what you see and what we can do with the results, what we can do with the outputs of our input. That is all. Hopefully this helps.